Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we are drawing quadratic graphs from a table. So let's start with a basic skill I need you super good at. I need you super good at being able to substitute into equations, linear or quadratic. Pause the video and double check you can substitute in these three cases. And hopefully you got the following answers: y is 8, y is 32, and y is 21. Now if you're struggling with those substitutions, you must go back to your building blocks, otherwise we're ready for this particular video. Now, a little brief introduction about what we're doing. Remember when we talked about quadratic sequences? And let's say the nth term of a quadratic sequence was n squared subtract 5. And that generated for you the following sequence: -3, -1, 4, 11, and 20. Now it just might be the case that I might want to represent this sequence in a different way. Suppose I said, well, this number here is my first number, this is my second number, this is my third number, this is my fourth number, and this is my fifth number. And say then I decided to draw a table like that, and I said, well, the number in position 1 is -3, the number in position 2 is -1, etc. So I've converted this sequence into a nice little table here. Furthermore, what I might decide to do is actually plot a graph of this table. So I've taken the same table here, and I've taken myself a piece of graph paper, and I've said to myself, well, why don't I think of these as x values? Why don't I think of these as y values? And let me plot them and see what I get. So let's do that. 1, -3 means 1 across, 3 down. 2, -1 means 2 across, 1 down. 3, 4 means 3 across, 4 up. 4, 11 means 4 across, 11 up. And 5, 20 means 5 across, 20 up. Now, let's remember what we're plotting here. Remember, this was the position or a place in the sequence. So this was the nth place. And remember, the term here had a formula. The nth term was given Tn is equal to, in the case before, it was n squared subtract 5. Now remember, n had to be a positive whole number because it was a position in the sequence. And these are what we're plotting against each other. But in general, let's say, I might want to plot any value of x, not just positive whole numbers. So I might want this to be 1.5 or -3.2, etc. And I would plot it against y numbers that were equal to, I square this number, x squared, take away 5. So in the case we've drawn, these are what we call discrete values, so we get a discrete graph. But in future we may want to draw what's called these quadratic graphs, where they are continuous. X can take any value at all, and as such y can take a continuous set of values. So that's the type of graphs we're going for, and they're called quadratic graphs. And now let's investigate what they look like. Now we have no restrictions on the x value. The x value can be decimals as well as whole numbers. So let's start. Pause the video and have a go at this if you think you can do this. Well, it says copy and complete the table and plot the resulting graph. I'm going to substitute in without talking. If you want to slow me down, you can slow the video down here. Now we're going to plot the x values with the y values as a set of coordinates, so I'll do that over here. Now, this is the key bit. We're going to join the dots here, and we have to join them with the smoothest curve as possible. So I'm going to try and do that with dots. And that's our attempt at the graph y is equal to x squared. Now, a couple of things to notice. It is what we call a parabola shape. This is a key word to remember. The shape of this graph is a parabola, and all graphs that are quadratic have highest power x squared will always be a parabola of some shape or another. And there's our first ever introduction to what one looks like. Let's go on and plot another one and see how that looks in comparison. Pause the video, have a go at this. Now again, this is a quadratic, and it will give us a parabola because the highest power is x squared. So now I'm going to substitute into this expression here. You may want to pause the video or slow me down in the video. I'm not going to talk through this. Okay, now we're going to plot those values on the graph over here. And let's try and join the dots. Now, we don't have any more information to go up along here, but the graph will, if you plotted more points, go up like that, as follows. Now, two things to point out of the two graphs we've drawn. They are both parabolas, okay? They both seem like they are what we would call U-shaped, okay? And they both seem symmetrical around a center line like that. That parabola is symmetrical around that line. In this case, the mirror line seems to be around this point here. And they both also have a minimum point, or what we call a turning point. And we're going to talk about a lot more about that later. But they have a turning point here, and so did the other one. There are other key features of the graph. It does cross the x-axis here and here, and it crosses the y-axis here. So they may be things we investigate in future. Let's have a go at plotting another quadratic. Pause the video, have a go. Again, I'm going to substitute in here, but I'm not going to go through it out loud. Okay, now let's plot these coordinates against each other. And joining the dots here, we get something as follows. Now again, there's not enough data to continue it, but if we did, it would end up looking something like this. Now, this one looks a bit different to the other two, and kind of similar in another type of way. Can you spot what is similar and different about this one and this one? Well, the first thing is, it is a parabola. It looks very similar, but it seems like it's upside down. It's what we call an N-shaped parabola. Parabolas, they will either be a U-shape or they will be an N-shape. And what determines that is, in the case of U-shaped, they had positive x squared coefficient. And in the case of N-shape, they have a negative x squared coefficient. You can see here we have -1 lots of x squared. But other than that, things are very similar. They have the same sort of curve, they have a line of symmetry, they have potentially a place where they cross the x-axis, they have potentially a place where they cross the y-axis, and also here they have what we mentioned before is as a turning point. In this case, it looks like what we might call a maximum point. It's where the graph reaches its maximum before it starts coming back down, whereas in the case before, we may have decided to call the turning point what's called a minimum, because it reached its minimum point and then started going back upwards. Okay, right, let's try one more. Pause the video, have a go. Now again, I'm going to let you do the substitution here. I will run through it, but I'm not going to talk through it. Now let's try and plot these coordinates. Just notice that one's going to go slightly off my graph, but I'll make an approximation. And let's try and join the dots. And it looks something like that. And if we had have continued the graph, it would have ended up looking like that. Again, we're back and we have a U-shaped parabola. Remember, we have positive 2x squared, and it had all the features we've previously talked about. And that's pretty much it for this video, other than to summarize our learning here. Now, here's a brief summary of the general features of quadratic graphs and the type of things we're going to start investigating and looking into calculating accurately. Now, a couple of features. A quadratic graph is always in what we call the shape of a parabola, like that. And if it's a positive x squared coefficient, it will be a U shape, like in this case here. And if it's a negative x squared coefficient, it will be an N-shaped parabola, like here. Some of the things we're interested in is it is symmetrical. Alright, there is a line of symmetry right down the middle of all parabolas, such that it's the same on both sides. It looks like the mirror image of each other. There is a turning point. On a U-shaped parabola, we might call it a minimum point. On an N-shaped parabola, we might call that turning point a maximum point. And also there are various points where these graphs may intersect with the x and y axis that we're interested in. Where it intersects with the y-axis, we call it the y-intercept, here and here, and when it crosses or interacts with the x-axis, we call it the x-intercept, here and in two places here. And they're the type of things that we are about to investigate in the forthcoming videos. Thank you very much for watching.